All right, hey everybody. So in this SOL review video, we're going to take a look at Unit 8, which was when we took numbers that were originally written in standard form and wrote them into scientific notation. Now, to start out with what that even meant, we started here with positive powers of 10 and negative powers of 10. And let me just review here that with the exponents, this 10 to the first power just means 10 by itself. When you see a 10 to the second power, that means to do 10 times 10. So you're doing it 2 times, which is what that is. So that's 100. If it was 10 cubed, that's when we now do another times 10, and that's when we get 1,000. And if it's 10 to the fourth power, we multiply by another 10, and that's where we would get 10,000. So there is a little shortcut that says if you see the exponent, it lets you know how many zeros you're going to have. So there's a 1, 1 0, 2 zeros, we see right here, 3 zeros, and we see 4 zeros right here. That shortcut also works with the negatives. So if it's 10 to the negative 1, you'll see that we have a 0 point. If it's 10 to the negative 2, there's 2 of the zeros. 10 to the negative 3, there's 3 of the zeros, and 10 to the negative 4 is right here. Friendly reminder that when you count the zeros, it does include the 0 point. So for example, if I'm looking at a 10 to the negative 5th, that would be a 0 point. So we've already got 1, 2, 3, 4, 5, and then we'd have a 1 right there. So that's what 10 to the negative 5th would look like. So this allows us to this little review allows us to remember then that the whole point of scientific notation is really that it's just a shortcut for multiplication. So take a look here, 2.45 times 10 to the fourth power. Now we already know 10 to the fourth power is 10,000. And we could take a calculator and multiply this out and say, okay, I'm going to get a 2.45 times 10,000. And we'd get our answer. But the whole purpose of scientific notation is that we don't have to use the calculator. We can just use the exponent to get the final number. So all I'm going to do is use the exponent here, y'all, and I'm just going to move it over 4 times. So take a look. And whoops, it should say 2.45, not 54. Let me fix that. So if I have a 2.45, I'm just going to use the exponent to move the decimal over once, twice, 3, 4 times. And you'll notice that this number now, 24,500, this is what it looks like, 24,500. So it is the same answer that I had in the calculator, 24,500. You can see that. So the point here is to be able to skip over having to use the calculator. So 2.45 times 10 to the fourth power is this number right here. And for the next one, if we saw a negative exponent, that just simply means to take the decimal and move it the other way. So if we have a 3.081, what we're going to do is we're going to go the other direction once, 2, 3, 4, 5, and there's where the decimal would be. So I'm going to fill in with zeros right here. And then if we include the 0 point, we can count 1, 2, 3, 4, 5 zeros in that answer. So if we look closely here, A and B, I think it's going to be A. We have 1, 2, 3, 4, 5, and that does include the 0 point. And I do want to point out that with the negatives here, you can still count in scientific notation to get the answer. Notice that up here it won't work with the positives. Like we're not going to pick an answer that has 4 zeros at the end. So I'll show you off to the side. A common mistake is for students to see the 2 and the 4 and the 5. And then they pick 4 zeros. They go 1, 2, 3, 4. And this would be the number that they're looking for. But this is 2 million something. So we're not going to multiply 2 times 10,000 to expect to get that. No, 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 no. Okay. So 2.45 times 10,000 should put us in the 24,000s. And again, when you just move it based on the exponent, 4 to the right if it was positive, because it was negative, we went back to the left. All right, so then let's say I give you a number here that starts out in scientific notation, and then I tell you what it's supposed to equal, and then I want to know what is the exponent that made that happen. So we've got a 1.45, and we're trying to make it 145,000. So I know I'm going to move it over twice. That's 1, 2. And then I need some zeros here, so it's going to be this overall answer. So once, twice, I got 3, 4, 5. It looks like we had to move this over 5 times. And if we replaced n with a 5, that would be 1.45 times 10 to the 5th. You might remember from up above that 10 to the 5th is just simply 100,000. So basically for this problem, we're multiplying 1.45 times 100,000. And I'll show you real quick in the calculator. If you do 1.45 times 10 to the 5th power, we get 145,000, which is what we wanted to get right there. So we found the value of n by simply taking the 1.45 and seeing how many times we would need to move the decimal. You can also work it this way, folks. You can start at the end of the number and say I'd go back 1, 2, 3, 4, 5 to make it a 1.45, but that's another way to prove that it would be a 5. We don't want to pick the -5 because this is not a super teeny tiny decimal. This is in the 100,000s, so this should be a positive exponent. Notice up above that the teeny tiny decimals are negative exponents and the really big numbers are positive exponents. All right, and now here we're on this one, which of the following are not equivalent to 10 to the -4. So let's go back up here and let's focus on this 10 to the -4. Because I see a negative, I can count 1, 2, 3, 4 zeros. That's including the 0 point. And when we say this number, y'all, we say 1/10,000th, which is what this fraction is. So we're going to pick, if we're picking ones that are not equivalent, this one is not equivalent, and -40 is not equivalent because this is 1/10,000th and this is 1/10,000th. So we're going to pick the two that are not equivalent to that. Friendly reminder that the way I would say this is in the thousandths place. So this is 1/1000th, which is what that fraction is saying. This is 1/100th. So that's what that fraction is saying. And this is in the tenths place. So this is 1/10th, which is what this fraction is saying. All right, so we've kind of reviewed a little bit about what's not equivalent. All right, so 10 to the -4, we know that's 1/10,000th. And so it's not going to be 10,000 and it's not -40. All right, now let's just review here if we saw the words 1 million versus 100 million versus 1 billion. I already wrote them in standard form if you want to jot those down in the boxes. So like 1 million looks like this in yellow, 100 million looks like this in green, and 1 billion looks like this in blue. So that's what they are in standard form. So now let's just see what these numbers look like in scientific notation. So for this one, again, if we want to know what the exponent needs to be, we can simply start at the end and say I'm going to go 1, 2, 3, 4, 5, 6. So scientific notation, this is 1 times 10 to the 6th. 10 to the 6th power is 1,000,000. So 1 times 10 to the 6th is what it looks like in scientific notation. Now for 100 million, let's count. We've got 1, 2, 3, 4, 5, 6, 7, 8. So 10 to the 8th is 100 million. So 1 times 10 to the 8th is how I write this in scientific notation. And for this one, for a billion, we're going to count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. This moved over 9 times. So if you see a 1 times 10 to the 9th, that is a billion. If you see a 1 times 10 to the 8th, that's 100 million. And if you see a 1 times 10 to the 6th, that's 1,000,000. Okay, so I just wanted to review what those numbers look like in scientific and standard form. All right, so if we need to compare these values, one thing that we can do to just kind of make a shortcut is actually just use the exponents. So let me just remind you in a calculator that 10 cubed, that's 1,000. We know that that's 1,000. So if I multiplied 4.2138, if I multiply that by 1,000, the number that I get on this side is 4,213.8. So I'm going to jot that down real quick. This was 4,213.8. All right, now on the other side, we've got a 2.2 times 10 to the 7th. Now 10 to the 7th is right in between these, so this would be 10 million. So we've got 10 million. That's 10 to the 7th. You can count 1, 2, 3, 4, 5, 6, 7 zeros. So if I multiply that by 2.2, we could see that this side is going to be a 22 million. So obviously this side at 22 million is way bigger than this one in the 4,000s. So the whole point, y'all, is that we don't even need the calculator. We can just use the exponents. If you focus in on the exponents here, you can see that this is a 3 and this is a 7. So 7 is bigger than 3, and that's enough for us to be able to make that decision. Multiplying something over here by 10 million is going to be way bigger than multiplying something by 1,000. So that's why we can just use the exponents as our shortcut. All right, now, so for the next one, same thing, because we have a 5 here versus a 4, we know that this side is bigger. Multiplying something by 100,000 is going to be bigger than multiplying something by 10,000. Now on this one, this is something that's interesting here. When these tie, now you care about these numbers. If these are equal, okay, now the 7 times is bigger than the 2. So only if the exponents tie do you care about those numbers, okay? All right, so in ordering from least to greatest, same thing. You can simply just use the exponents. I see a 4, an 8, a -2, a 4, and a -6. So I'm going to actually, just because of space, I'm going to actually bring this one down here. I know there's still one more problem that we would need to look at, but because of space, I'm just going to bring the ordering one down below. So between 4, 8, -2, 4, and -6, I think we all would agree that -6 is the smallest one. So the first one we're going to have is a 2.37 times 10 to the -6. That one's the smallest. All right. Now we do have a -2 here, so we've got 5.96 times 10 to the -2. So we've taken care of the negative ones. Now when we're in the positives, we actually are tied here at the 4. So because we're tied, we care about these numbers. So I'm going to go with 4.78 times 10 to the 4th. Then the 6.02 times 10 to the 4th. And the last one with the 8, so we've got 3.4 times 10 to the 8. So it does work when you're ordering to just simply look at the exponents. And now there's only one final thing that I have left that I wanted to review with you guys, and that's how to determine if something is correctly written in scientific notation or not. So out of these, we have 1, 2, 3, 4, 5 options, and we're going to pick which ones are correctly written in scientific notation. And to spot that, the first number has to be a number between 1 and 10, okay? So just ask yourself, is this a number between 1 and 10? It sure is. Is this a number between 1 and 10? No, this is too small, so we will not pick this one. Is this a number between 1 and 10? It sure is. Is this a number between 1 and 10? It sure is. Is this a number between 1 and 10? No, it is not, so we will not pick that. So the first option here, the third, and the fourth would be the 3 numbers that are correctly written in scientific notation. That concludes this video. Thank you for watching.